All right, here we go, guys. I'm just gonna remind you, Monday is our next quick quiz. It'll have a SOAR question, S equals theta R on it. All right, what we did yesterday, and then it'll have probably a question from what we're about to do right now. All right, first thing here, there's a couple degree measures I really need you guys to know right off the top of your head versus taking the time to convert them. All right, yesterday I showed you a couple that were on the line, the quadrantal ones. 90 was pi over 2. 180, hopefully we all know it by now, is what? Is just pi. 270, 3 pi over 2, and then 360, 2 pi. All right? There's 3 more I'm going to show you today that are going to come up more and more in our problems that I'd like you to know them right off the top of your head versus just trying to convert them. All right? And today you're going to have to flip back and forth a lot, but you're going to see how much we're going to use 30, 60, and 45. And hopefully by the time you leave today, you'll know them off the top of your head instead of trying to convert them. All right, so let's start with 30 degrees. 30 degrees in radians, pi over 6. Sorry, pi over 6, 30 degrees. And again, it makes sense because what's pi again? 180, right? So 180 divided by 6 gives you that 30. 60, pi over, what do you think? 3, yep. Pi over 3. And then 45, pi over 4. Okay, so those are the 3 I'm going to try to hopefully get you guys to know off the top of your head by the time you leave. All right, so here's what I'm doing with you today. You guys have had a lot of experience finding a reference angle for you. So today, I'll give you the reference angle. What was the angle to begin with? So kind of going in reverse, all right? You'll know what the reference angle is and the quadrant. I want to know what was the actual angle to begin with. Hey, here we go. Part A, I'm in quadrant 4. Reference angle is pi over 6, which is pi over 6. Look back if we have to, right? Pi over 6, 30-degree reference angle, all right? So if we want a little visual, not required in this problem, but if we want a little visual, we're in quadrant 4. Remember, how's the reference angle formed? Which axis? X or Y? X-axis and the terminal side, right? So here's my reference angle. And you guys have already told me pi over 6 is what? 30 degrees. So that's 30 degrees right there. What am I looking for? What is that angle in quadrant 4? Right? What is that actual angle in quadrant 4? Now remember, we're in quadrant 4, so your answer should be between what two? 270 and 360. All right, talk to me. How can I find this angle in quadrant 4? All right, we're calling it theta. So that angle is going to be, now don't get confused with the theta from yesterday. Nothing to do with it. Just means an angle. Thoughts, Gabby?
Could you do 360 minus 30?
Yeah, I like it. If I went all the way around, it would be 360 minus that reference angle of 30. So that angle is going to be? Okay, 330. Good job. 330 what? Degrees. Everyone want to read the directions for me, though? Put in radians. But wait, whoa, we ready for this? This is the highlight of my day right here. All right, I've been giving tests to all my geometry kids. First time I've taught today, so this is a big highlight here. I'm going to show you, you don't have to convert it. Okay, remember you would have to multiply by pi over 180, reduce it. Watch how quick this can go now. Pi over 6 was what again? What in degrees? 30, right? In your calculators right now, if you have them out, how many 30s go into 330? How many 30s go into 330?
11.
How many?
11.
11? Okay, ready? Pi over 6 was 30 degrees, right? That was 30 degrees. How many 30s went into 330? 11 pi over 6. We're done. Okay, so 30, because I knew pi over 6 was already 30. How many 30s went into 330? 11 of them. So 11 pi over 6, also known as 30. All right, so I'm going to have you try to do the math a little quicker too. Questions how we went from 330 to 11 pi over 6. Now look, if you don't like this at the end, you don't feel comfortable, am I going to mark you off if you multiply this by pi over 180 and go to your calculator and reduce? Not at all. Not at all. Okay, whatever gets the job done. All right, another one. All right, now I'm in the third quadrant. I'm in quad 3. What's pi over 3 again? 60 degrees, right? 60. So think of an angle on the x-axis in quadrant 3. That's 60 degrees. Now be careful. Hey, remember, I'm looking for the angle in quad 3. So at least you know your answer should be between what 2 degree measures? 180 and 270. So I should have some angle between 180 and 270 here. Okay, how are we going to use that information to find the angle here? Okay, if I do 180 minus 60, that's going to give me 120, which puts me in quadrant 2 now. My angle's in quadrant 3.
So 270.
No, never want to touch the 270, right? Because that's not dealing with reference angles. I like the 180 and the 60, but I don't like subtracting them. Why not? I want to add them to get right. Watch, ready? Go right. Let me get that arrow. Can I get that arrow out of there? There we go. All right, watch. Here you go. From there to there is already what? 180, but then I got to go an extra 60 degrees. All right, so everyone see if I subtracted, if I subtracted, I'd be going backwards in the quadrant 2. So yeah, I want to do 180 plus that 60. And that'll give me a angle in the third quadrant of 240. All right, let's see. Can we do this without having to convert it? Can we put that in radians? What was pi over 3 again?
60.
That was 60, right? That was 60 degrees. How many 60s go into 240 now? How many 60s go into 240, Marty? So that's 4 pi over 3. Go ahead, ask. No, and again, if you want to just convert. I'm okay with it. I just think a lot of you guys are a pretty strong group this year. I'm lucky, right? I think you guys can handle without having to convert it. All right, how about in quadrant 2? What's pi over 4 again?
45.
45 degrees now, right? 45 degrees in quadrant 2. So make an angle on the x-axis in quadrant 2. Call that 45 degrees. So now, remind me, my angle should be between what 2 degrees now? 90 and 180 now, all right? If you get something else, we know it's wrong. So I need this angle right there. How can I find that? Given the reference angle, Emma, thoughts?
180 minus 45.
Now I can do 180, back it up, minus the 45. If I wanted to go in quad 3, I would add it. And that'll be 135? Yeah. Okay, can we quickly convert that into radians now? I know my reference angle was 45 pi over 4. How many 45s go into 135?
3.
So 3 pi over 4 radians. Questions there? Okay, where else can we use the 30, 60, and 45? Here you go, sketch an angle. Sketch an angle. I say no calculator, but if you need to use one, use one. Sketch 5 pi over 6. Usually yesterday, the day before, we'd have to convert that into degrees, but ready? What do we know pi over 6 is already? We already know that's, right? You got to look back. You got to look back. Pi over 6 is 30, right? Times 5. This is just what, 150 degrees, yeah. It just saves time converting. Now, hey, I don't have a trick for you if it's not pi over 3, pi over 6, or pi over 4. I don't. We'd have to multiply it by 180 over pi. I don't have a little trick for that. Any other ones, though. All right, where's 150? This should go quick now. Quadrant 2, closer to 180 or 360? 180. Where's my arrow going? Clockwise or counterclockwise? Counterclockwise. Yep. Bless you. And it also says graph it and then find the reference angle in radians. All right, so I have 150 degrees. What's the reference angle?
30.
What's my reference angle? This angle here, 180 minus 150, so 30. But it says make sure it's in radians. What's 30 degrees in radians?
Pi over 6.
Pi over 6. I wonder if we'll see a pattern here. Ready for the next one?
Yeah.
Negative pi over 4. What's pi over 4?
45.
45. So I want you to graph negative 45 degrees. Yep.
And then is the reference angle negative?
We'll talk about it in a second. What quad am I going in here?
4.
Quadrant 4. Yep. Oh, this is a first, huh? I think it is. Where's my other side going to go? Yeah, halfway, right? It's not closer to 90. It's not closer to 0. It's right halfway in between. And where's my arrow going? Yep. All right, ready for the reference angle? Reference angle, which is x-axis and terminal side.
45.
That's a what?
Is it negative 45 or just 45?
Okay, well, let's answer that question now. What did we always say about reference angles?
They're always positive.
Always positive, right? They have to be less than 90 and always positive. So we answered our own question. And it's got to be in radians, though.
Pi over 4.
Yep. And anybody starting to establish a pattern between the angle in radians I give you and the reference angle? Huh? 5 pi over 6, and my reference angle ended up being pi over 6. Right? Negative pi over 4, pi over 4. 7 pi over 3. Guesses before we get there what the reference angle is going to be?
Pi over 3.
Pi over, maybe. We'll see, right? All right, let's graph it first. What is pi over 3?
60 degrees.
60, right? Times 7.
420.
420 degrees. Oh, we're going to have a loop-de-loop here, huh? A little loop-de-loop. Make it a little smaller, though. I get nervous. I start sweating. Can we make that a little smaller? What actually is this angle?
60.
60? All right, so what quadrant is it going to end up in? Quadrant 1, but just remember, I'll graph 60 closer to 0 or 90? 90, but remember here, am I just going to go here? No, that wasn't 420, that's 60. So I go 360 and the extra. All right, reference angle.
30.
Be careful.
Or 60.
We're going on the y-axis if we go 30 on me. What's my reference angle?
60.
60, right? Oh, shocker. What's 60 in radians?
Pi over 3.
So you guys were correct. I can just look at the radians and figure out what that reference angle is going to be. All right, any questions working with these before we get to these last two? And you guys should probably have enough time to complete the assignment today. All right, I think we can do this without even graphing now. Let's see. State the quadrant and the reference angle. All right, 7 pi over 6. Can we quickly put that into degrees? Pi over 6.
30.
30 times 7.
210.
There it is. All right, let's first talk. What quadrant does 210 put me in? Quadrant 3, right? And it says find the reference angle now. Now we can do it old school, You know, I could throw up a graph and put 210 and highlight the angle, or just by looking at the radians here. What do you think the reference angle is going to be? What did we just multiply by 7?
30.
Pi over 6, right? Or 30 degrees, yeah. But remember, if my answer is in my original question's in radians, so is my answer. So pi over 6. And again, I'm going quick because that's what I'm trying to teach you today. If you guys today on the assignment wanted to go, all right, here's 210. Here's 210 right there. And then try to find that reference angle. That's fine. It's still going to be 30 degrees. All right, we're next. Negative 2 pi over 3. Pi over 3.
60.
60 times negative 2, right? Negative 120. So that's what this is quickly in degrees. All right, let's find the quadrant. Not a big fan. You could do it. I know most of you could probably do that, right? Go clockwise, 120, but I'm always a big add 360 guy. So that's 240. That makes me feel a little bit more warm inside. Where's 240? Quad 3. And reference angle for 240? Pi over 3, 60 degrees. Yep. Now again, I don't know if it's this assignment you're about to do, but if it's not 30, 60, or 45, hey, let's just say it's 80 degrees. All right, I don't have anything for you. So you have to convert that into radians. All right, there are some degree measures you're going to have to convert. Because I don't, or, you know, I think it's pi over 10. I don't have anything for you. But at least you can go, you can still go quick because what's pi?
180.
180. So you can plug 180 in every time you see pi. All right, questions? What did I give you today? A Delta Math or out of the pack? I think it's out of the packet, right? Both? Whoa, look at me, huh? All right, there you go. All right, let's get going. You guys know the answer keys up on Classroom. Finish it. Finish it.